Hi guys. For those of you who don't know me, I'm Eric. Uh, I wanted to make a video, or just to see how to test out if the videos help you guys. I wouldn't say I have the best understanding of the stuff we're going over, but I generally understand, and I wanted to see if I could help you guys out because I know we don't get a whole lot of practice time in class. So let me know if these problems I'm doing on the video are helping you guys. But if you don't think they help, just let me know as well, and I just won't waste my time. But I'm going to start with Chapter 10 homework number 37. There's two parts to it. I'm going to start with Part A, which is from Figure 1033, and it's number basically the the circuit C. So for this problem, it gave us a voltage of 100 volts, and it wanted us to find the voltage across each capacitor. So to do these types of problems, the first thing you need to do is to find the capacitance total for capacitors in parallel, which is the first step we should do here. So for capacitors in parallel, these two guys here, we would add them together, and this would give us an equivalent capacitance of 9 microfarads. This 9 microfarad is in series with this 6 microfarad. When capacitors are in series, you take the reciprocal of the total. So our capacitance total for this whole circuit would be 1 over 1 over 6 plus 1 over 9, which gives us 3.6 times 10 to the minus 6 farads, or 3.6 microfarads. Sorry about that. I should have done that in the first place. Now, I can't explain this if it makes sense for you guys. I don't do the whole large problem if they're the same prefix. If you make them all the same prefix, you don't have to worry about the 10 to the minus whatever when you're going through the problem. But that being said, we know that our capacitance total is 3.6 microfarads. The next step to do would be to find your total charge for the system, Q total, which is equal to your capacitance total times your system voltage, which gives us 3.6 times 10 to the minus 6 times 100. That gives us 360, we'll call it microcoulombs, but it's 10 to the minus 6 coulombs. Once you have that, you can find the voltage for each one of the capacitors. So step 3, we'll start with V1. That's why I have the blue to match that 6 microfarad capacitor. We can take this same formula that we just used, rearrange it, and find that V1 is equal to your charge total divided by your capacitance. So we get 360 times 10 to the minus 6 divided by 6 times 10 to the minus 6. These two will cancel out, and we wind up with 60 volts. Okay. Now, before we move on to the 5 and 4 microfarad capacitors, we should run a check for ourselves. Here, we call that voltage VC. If we use KVL, we'll know that VC should equal 100 minus 60, which is 40. So that's our check once we do this. Now remember that any component in a circuit that's in parallel with each other, which these two are here, the voltage VC would be seen by this one and this one. They both have the same voltage. So we know that these two in combined is 9 microfarads. So using the same formula, V, we'll call it V2, excuse me, is equal to 360 times 10 to the minus 6 over 6 times 10, excuse me, not 6, 9 times 10 to the minus 6, which is this equivalent capacitor. Basically, if I could redraw this, I'll redraw this real quick. It would equal that 9 microfarads. So this voltage is seen by the 4 and the 5 microfarads. These two cancel out, and we're winding up with 360 divided by 9, which is equal to 40 volts. So to review real quick, to solve these problems where you have a voltage source and capacitors, and you want to know the voltage for each capacitor, the first step is to find your total capacitance. Then you want to find your total system charge. Total system charge is equal to your capacitance total multiplied by your voltage total. From there, you can find your voltage across each capacitor by dividing the charge in coulombs divided by your capacitance. For capacitors that are in parallel, remember that they both all capacitors in parallel experience the same voltage potential. So they will you'll have to find the total capacitance for capacitors that are in parallel. If you enjoyed this, if this helped you out, please let me know, and I can make more videos. Thanks.